Welcome back everyone. This is the third video lecture for the chapter motion. Earlier we have learned what is motion, what is rest, why are these concepts relative. Then we have discussed about distance and displacement and how to differentiate between them and what is their usefulness. Today we will discuss two types of motion, or in fact the main two types of motion, and these are uniform motion and non-uniform motion. So today our discussion will be on uniform motion and non-uniform motion. So to understand what is uniform motion and what is non-uniform motion, we will study this through an activity. This activity is given in the NCERT textbook. If you have the soft copy, you can see from there. Okay. Now, in this activity, we have two objects that are moving. Let us name one of them as A and the other object is B. Two objects are there. One is A and other is B. And both of these objects are moving with time. That means they are in continuous motion. Okay. Now, the first column gives the list of different times at which their respective distances are measured. You can see here in the time column 9:30 AM. I hope you can see it, 9:30 AM. In the second row, it is written 9:45 AM. That means a difference of 15 minutes. Then we have 10 AM, 10:15 AM, 10:30 AM, 10:45 AM and 11 AM. So these time intervals have a difference of 15 minutes between them. Okay, they have a difference of 15 minutes between them. In the second column, it is the distance traveled by object A in meters. Okay. In the second column, we have distance traveled by object A in meters. In the third column, we have distance traveled by the object B, which is again in meters. So we will slowly study each of this set of data, and then we will try to understand what is uniform motion and what is non-uniform motion. Now let us consider this case. The time is 9:30 AM. The time is 9:30 AM. Distance travelled by object A in meter is 10 meter. 9:45 AM, that means after 15 minutes, the distance travelled by object A in meter is 20 meters. That means in 15 minutes, object A has covered a distance of 10 meter. In 15 minutes, object A has covered a distance of 10 meter. Now when the time is 10 AM, the distance covered by object A in meter is 30. So this time it has covered a distance of again same 10 meter. When the time is 10:15 AM, the distance covered by object A in meter is 10 meter. Similarly for 10:30, 10:45 and 11, if you calculate, each of these distances are 10 meter. Okay? Each of these distances are 10 meter. Now you see, these time intervals, all these time intervals are of 15 minutes. That means since all the time intervals are same, let us write equal time intervals. Equal time intervals. Why we are writing this? Because this time interval is 15 minutes in each case. Now you see, corresponding to each equal interval of time, the distance covered is also same. That means for 15 minutes interval here, distance covered is 10. 15 minutes interval here, again the distance covered is 10. 15 minutes interval, distance covered is 10. So the distance covered in this time interval is also same. So let us write equal distance. Equal distance covered. So in the first case of object A, so in case of object A, in equal intervals of time, equal distances are covered. In equal intervals of time, equal distances are covered. Okay. Now let us go to the second object. The second object at 9:30 AM has a distance marked as 12 meter. 9:45, 15 minutes interval, it is 19 meter. So that means in 15 minutes it has moved a distance of 19 minus 12. 19 minus 12 gives us 7 meter. 10 AM, its distance is 23 meter. So 23 minus 9, it's 4 meter. 10:15, it's 35. Okay, so it is 12. 10:30, 2. 10:45, 4, and this is 3. Now you note this. Here the intervals of time are still same. Okay, the intervals of time for the second objects are still same. So we write equal time intervals. Equal time intervals. Okay, in equal time intervals, let us see the distance that are covered. In the first interval of 15 minutes, the distance covered is 7 meter. In the second interval of 15 minutes, the distance covered is 4 meter. In the third interval of 15 minutes, the distance covered is 12 meter, and so on. That means in equal time intervals, this time the distance covered is not same. In equal time intervals, this time the distance covered is not same. So we write unequal distance covered. Unequal distance covered. So you note this. Here in equal time intervals, equal distances are covered. Here in equal time intervals, unequal distances are covered. Here in equal time intervals, equal distances are covered, and here in equal time intervals, unequal distances are covered. Okay? When this case whenever you encounter motion having equal time intervals and equal distances are covered, that kind of motion is known as uniform motion. And if in equal time intervals you see that, you observe that the moving object is covering unequal distances. Unequal distances are covered in equal time intervals, then that kind of motion is non-uniform motion. So equal intervals of time, distances covered are equal, we classify that type of motion as uniform motion. And in equal intervals of time, if the distances covered are unequal, then we classify that motion as non-uniform motion. Okay, in your day-to-day life you can see many examples of these types of motion. Okay, it is difficult to find uniform motion, but you can find many examples of non-uniform motion in your day-to-day life. I hope you will connect these examples with your day-to-day experience, and whenever some object is moving, be it a car, a bus or a train, you will think about it whether this is uniform motion or non-uniform motion. This way your concepts will get more clear. So I hope you have understood the concept, and in the next video lecture we will describe how to measure this particular rate of motion. Okay, then we will discuss average speed, average velocity and their associated numericals. Thank you.